Your Chevrolet has a hidden reset function that can fix transmission problems, clear phantom check engine lights, and restore lost performance in under 30 minutes using nothing but a 10mm wrench. Dealers charge $150 minimum for this exact same procedure, but I'm about to show you how to do it yourself for free. This works on Silverados, Tahoes, Suburbans, Camaros, Corvettes, and virtually every Chevrolet built after 2000. The ECM Reset Secret dealers charge $150 for. Let's start with what this reset actually is, and why dealerships don't want you knowing about it. Your Chevrolet's engine control module, the ECM, is essentially a computer that manages everything from fuel delivery to transmission shift points. Over time, this computer stores adaptive data based on how you drive, sensor readings, and operating conditions. When this data gets corrupted or outdated, you experience problems that seem impossible to diagnose. Here's what mechanics won't tell you. That adaptive data can be completely wiped clean by disconnecting your battery for an extended period. This forces every computer module in your truck to reset to factory defaults and relearn everything from scratch. Dealerships call this an ECM reset or computer reflash and charge $150 to $250 for the service. But you can do the exact same thing in your driveway with a basic wrench. I've been working on Chevrolets for over 17 years, and I've seen this simple reset fix problems that had owners convinced they needed $1,000 repairs. Transmission hunting between gears, rough idle that wouldn't go away, check engine lights for phantom codes, sluggish throttle response. All of these can be caused by corrupted adaptive data, and all of them can be fixed with a proper battery disconnect reset. The beauty of this trick is that it costs absolutely nothing if you already own a 10mm wrench. No scan tools, no special equipment, no dealership visit required. Just your driveway, 30 minutes of your time, and the knowledge of how to do it correctly. That last part is critical because most people disconnect the battery wrong and wonder why nothing changes. There's a specific procedure that mechanics use to ensure every capacitor drains and every module truly resets. Dealerships know this works, which is why they offer it as a service, but they're not about to advertise that you can do it yourself for free. That would eliminate a significant revenue stream from confused customers who bring vehicles in for electrical gremlins and computer glitches. The service advisor walks to your truck, disconnects the battery for 20 minutes, reconnects it, drives it around the block, and charges you $200. You just learned how to save that money forever. When your Chevrolet actually needs this reset, before you run out and start disconnecting batteries randomly, you need to understand when this reset actually helps versus when it's a waste of time. There are specific symptoms that indicate corrupted adaptive data, and recognizing these symptoms saves you from unnecessary work. The most common sign is transmission behavior that changed suddenly without warning. Your 6-speed or 8-speed automatic was shifting perfectly fine, then overnight it started hunting between gears, shifting hard, or refusing to downshift when you need power. No warning lights, no obvious mechanical failures, just weird shifting behavior that appeared out of nowhere. This is classic corrupted transmission, adaptive data, and a reset fixes it about 70% of the time. Phantom check engine lights are another major indicator. You get a check engine light, scan the code, and it's something generic like P0420 catalyst efficiency below threshold or P0171 fuel system too lean. You replace the parts, clear the code, and 3 days later, the light comes back. The parts aren't defective. The computer is reading bad adaptive data and throwing codes based on false information. A complete reset wipes that bad data and often solves the problem permanently. Rough idle that developed gradually over time is another symptom. Your Silverado used to idle smooth as glass, but now it shakes and vibrates at stoplights. You've replaced spark plugs, cleaned the throttle body, checked for vacuum leaks, and nothing helps. The idle air control data in the ECM has drifted so far from factory specs that the computer can't compensate anymore. Reset the computer and force it to relearn proper idle control from scratch. Throttle response that feels delayed or sluggish is a big one, especially on drive-by-wire systems used in every Chevrolet since 2005. You press the gas pedal, and there's a noticeable lag before the engine responds. This isn't a mechanical problem. It's the throttle position sensor, adaptive data, telling the computer to soften throttle inputs. A A reset restores factory throttle mapping and brings back instant response. Fuel economy that dropped mysteriously without any mechanical changes is another sign. You used to average 18 miles per gallon in your Tahoe, now you're getting 14, and nothing has changed about your driving habits. The fuel trim data has adapted to compensate for a sensor reading that's slightly off, and now the computer is dumping extra fuel unnecessarily. Reset the adaptive fuel trims and watch your mileage climb back to normal. One critical warning though: if you have hard mechanical failures like a slipping transmission with burnt fluid, a misfiring engine with bad compression, or actual sensor failures confirmed by diagnostic testing, this reset won't fix anything. You can't reset your way out of worn clutch packs or broken piston rings. This reset specifically addresses computer-related problems caused by bad adaptive data, not mechanical wear and damage. The complete step-by-step reset procedure. Here's the exact procedure mechanics use to perform a complete ECM reset. Follow these steps precisely, because missing even one step can result in an incomplete reset that doesn't solve your problems. First, park your Chevrolet on level ground and turn off the engine. Make absolutely certain the engine is completely off, not in accessory mode. Remove the key from the ignition if you have a traditional key, or make sure the key fob is far away from the vehicle if you have push-button start. This ensures no modules stay partially powered during the reset process. Open the hood and locate your battery. On most Silverados and Tahoes, it's in the engine bay on the passenger side. On Camaros and Corvettes, it might be in the trunk. Find the negative battery terminal. It's the one marked with a minus sign, and usually has a black cable attached. You'll need a 10mm wrench or socket to loosen the terminal clamp. Here's where most people make their first mistake. They disconnect the negative terminal and immediately reconnect it 30 seconds later. That's not long enough for a complete reset. You need to drain every capacitor and every module throughout the entire vehicle. Here's the critical step that mechanics use but never tell customers about. After disconnecting the negative terminal, turn on the headlights. Yes, with the battery disconnected. The headlights won't turn on, but this creates a path to ground that helps drain residual power from the system faster. Next, press the brake pedal firmly, 10 to 15 times. Each press drains a little more power from the brake system modules and ABS controller. Then press the horn button several times. Again, nothing will happen, but you're draining the airbag system and body control module. Open and close all the doors. This cycles the door modules and interior lighting systems, draining their capacitors. If you have power seats, move them back and forth a few times. Same with power windows. Every electrical component you activate without the battery connected helps drain the system more completely. Now comes the waiting period. Leave the battery disconnected for a minimum of 30 minutes. An hour is even better, especially if you're dealing with stubborn transmission problems or persistent check engine lights. During this time, every module in your vehicle is slowly draining to 0 voltage. When voltage reaches 0, all adaptive data erases completely, and the modules reset to factory defaults. After 30 minutes to an hour, reconnect the negative battery terminal and tighten it securely. Don't just hand tighten it. Use the wrench and make sure it's snug. A loose battery connection can cause electrical problems that mimic the exact issues you're trying to fix. Before starting the engine, turn the key to the on position without starting. Let it sit for 10 seconds. This gives the modules a chance to power up and run their self-diagnostic checks. You might notice warning lights on the dash that weren't there before. Don't panic. These are normal and will clear themselves during the relearn process. Now start the engine, but don't touch the accelerator pedal. Let it idle completely untouched for at least 2 minutes. The computer is relearning idle air control and basic engine parameters during this time. If you touch the throttle, you interrupt the learning process. What's really happening inside your computer? Understanding what actually happens inside your Chevrolet's computer during this reset helps you appreciate why it works and when to use it. Modern vehicles have multiple computers networked together, and each one stores specific types of adaptive data. The engine control module stores fuel trim data, which is how much the computer adjusts fuel delivery to compensate for variations in sensor readings, fuel quality, and engine wear. Over 50,000 miles, these fuel trims can drift significantly from factory specs. Short-term fuel trims might show plus 15%, meaning the computer is adding 15% more fuel than the base calibration calls for. This happens when an oxygen sensor reads slightly lean, a mass airflow sensor reads slightly low, or a dozen other small variations accumulate over time. When you reset the ECM, these fuel trims return to zero. The computer starts fresh with factory fuel maps and relearns proper fuel delivery based on current sensor readings. If a sensor was giving bad readings before, the reset forces the computer to recognize the bad data and potentially throw a code identifying the actual problem instead of just compensating silently. The transmission control module stores shift point data, line pressure adaptations, and clutch pack wear compensation. Every time your transmission shifts, the computer measures how long the shift takes, how much clutch slippage occurs, and how smooth the transition feels. Over time, it adjusts shift timing and line pressure to compensate for normal clutch wear and fluid degradation. But sometimes this adaptive data goes wrong. The transmission might have shifted hard once because you were towing a heavy trailer, and the computer learned that hard shifting is normal. Now it shifts hard all the time, even when you're driving empty. Or the opposite happens. The computer compensated for old worn fluid by increasing line pressure. Then you change the fluid to fresh synthetic. Now the computer is using high line pressure with fresh fluid, causing harsh shifts. A reset wipes all this adaptive data clean. The transmission control module returns to factory shift programming and relearns everything based on current conditions. Fresh fluid, current driving style, actual clutch wear, all measured from scratch without any historical baggage affecting decisions. The throttle control module stores pedal position data and throttle response curves. This is especially important on newer Chevrolets with electronic throttle control and multiple driving modes like tow haul, sport, and eco. The computer learns how aggressively you typically drive and adjusts throttle mapping accordingly. If you drive gently most of the time, it softens throttle response. If you drive aggressively, it sharpens response. When you reset this data, throttle response returns to factory calibration. Some drivers immediately notice their truck feels more responsive because the computer had learned to be lazy based on gentle driving habits. Others notice smoother response because the computer had learned to be too aggressive. The critical relearn drive cycle. After reconnecting the battery and letting the engine idle, you need to perform a proper relearn drive cycle. This is where most people fail and wonder why the reset didn't help. You can't just reset the computer and immediately drive normally. The modules need specific driving conditions to relearn proper operation. Here's the exact relearn procedure that Chevrolet technicians follow, pulled directly from service information that most owners never see. This drive cycle typically takes 20 to 30 minutes of continuous driving and includes specific operating conditions that trigger the computer's relearn routines. Start with a cold engine if possible. Let your truck sit overnight, then perform the reset in the morning. A cold engine allows the computer to relearn cold start parameters, which are different from warm engine operation. After the initial 2-minute idle period, you're ready to drive. Pull out of your driveway and drive gently for the first 5 minutes. No hard acceleration, no aggressive throttle inputs. Keep speeds under 35 miles per hour and make smooth stops and starts. This allows the computer to establish baseline idle control, basic fuel trims, and transmission shift points at light loads. After 5 minutes of gentle driving, find a safe stretch of road where you can accelerate moderately. Accelerate smoothly from a stop to 50 miles per hour. Hold that speed for 30 seconds, then decelerate smoothly back to a stop. Repeat this 3 times. This teaches the transmission proper shift points under moderate load and helps the computer learn wide-open throttle sensor ranges. Next, find a highway and drive at a steady 55 to 65 miles per hour for at least 10 continuous minutes. No accelerating or decelerating, just steady cruise. This is critical for learning closed-loop fuel control, which is how the computer uses oxygen sensor feedback to fine-tune fuel delivery. You need sustained, steady-state operation for the oxygen sensors to stabilize and for the computer to calculate proper fuel trims. During this highway cruise, turn on the air conditioning for 5 minutes, then turn it off for 5 minutes. This helps the idle air control system learn how to compensate for AC compressor load. Many rough idle problems are specifically related to improper idle compensation when the AC kicks on, and this part of the relearn cycle addresses that directly. exit the highway, and perform 5 to 10 gentle stops at traffic lights or stop signs. The transmission needs to learn proper shift points during deceleration and coming to a complete stop. This is when many transmission adaptive learning occurs, particularly for the torque converter lockup clutch and the 1 to 2 downshift that happens as you slow down. Finally, if your Chevrolet has multiple driving modes, cycle through each mode during the relearn drive. Spend 5 minutes in tow haul mode, 5 minutes in normal, and if you have sport mode, 5 minutes there too. Each mode has its own adaptive parameters, and the computer needs to establish baselines for all of them. After completing this drive cycle, park the truck and let it idle for 2 minutes before shutting off. This gives the modules a chance to save all the learned data to memory. Some modules only write learned values to permanent memory during key off, so if you shut the engine off immediately after driving, some of that learned data might not save properly. Transmission problems, this reset fixes. The transmission is where this reset shows the most dramatic and immediate results. I've personally seen 8-speed automatics that were scheduled for complete rebuilds return to perfect operation after nothing more than a proper reset and relearn cycle. Gear hunting is the most common problem this fixes. You're cruising at 45 miles per hour, and the transmission can't decide if it wants to be in 4th gear or 5th gear. It shifts back and forth every few seconds, creating an annoying surge sensation. This happens because the transmission adaptive data has confused shift points based on accumulated bad data. Maybe you towed a heavy load once and the computer learned to hold lower gears longer. Now it's applying that logic to normal driving, causing the hunting behavior. After a reset, the transmission control module goes back to factory shift programming. Within 20 miles of driving, you'll notice the hunting stops completely. The computer relearns proper shift points based on current driving conditions without any historical confusion affecting its decisions. Harsh shifts, particularly the 1 to 2 upshift and the 4 to 3 downshift, are another problem that responds incredibly well to this reset. The transmission was shifting smoothly, then started banging into gear hard enough to jerk your head. No warning, no gradual degradation, just suddenly harsh shifts that feel like something broke. 9 times out of 10, this is corrupted line pressure adaptive data. The transmission control module adjusts line pressure to compensate for clutch wear and fluid condition. If the data gets corrupted, it might command excessive line pressure that causes harsh shifts or insufficient pressure that causes slipping. A reset returns line pressure to factory specifications and lets the module relearn proper pressure based on actual current conditions. Delayed engagement is another big one. You shift from park to drive, and there's a 2 or 3 second delay before you feel the transmission engage and the truck starts to move. This is incredibly annoying in drive-thrus and parking lots, and many owners are told they need a transmission rebuild to fix it. Before spending $4,000 on a rebuild, perform this reset. Delayed engagement is often caused by the transmission control module's learned shift timing being too conservative. The computer is waiting too long before applying clutch pressure, creating that frustrating delay. Reset the module and watch engagement return to immediate response. Refusal to downshift on the highway is another symptom that drives owners crazy. You're cruising at 65 miles per hour. You need to pass someone. You press the throttle to the floor, and nothing happens. The transmission just stays in 8th gear, lugging the engine, instead of downshifting to 5th or 6th gear for power. This is the transmission adaptive data, telling the computer to stay in high gear for fuel economy, even when you're demanding power. A proper reset and relearn cycle fixes this by teaching the computer to recognize wide-open throttle as a demand for power, not a request to stay in high gear. After the relearn drive, where you do several moderate accelerations, the transmission will downshift properly when you need it. Engine problems that disappear after reset. The engine side benefits from this reset just as much as the transmission, though the improvements are sometimes more subtle. Rough idle is the most noticeable improvement. Your Silverado used to idle at a smooth 700 RPM. Now it shakes and hunts between 600 and 800 RPM at every stoplight. This is corrupted idle air control data. The computer has lost its learned baseline for how much air the engine needs at idle, so it's constantly adjusting, trying to find the right amount. This creates the hunting sensation and rough idle quality. A reset wipes that corrupted baseline and forces the computer to relearn proper idle air control from scratch. Within 2 minutes of the initial post-reset idle, you'll hear and feel the difference. The idle stabilizes at a consistent RPM and the shaking disappears. This is one of the most dramatic and immediately noticeable improvements from this reset procedure. Throttle lag is another problem that vanishes after a reset. You press the gas pedal and there's a noticeable delay before the engine responds. This isn't a mechanical problem with the throttle body or accelerator pedal. It's the throttle position adaptive data that has learned to soften your inputs for smoothness or fuel economy. Reset that data, and throttle response returns to factory mapping. The engine responds immediately when you press the pedal, giving you back the sharp throttle feel the truck had when it was new. This is particularly noticeable on Silverados, with the 5.3 or 6.2-liter engines that have plenty of power but felt neutered by soft throttle programming. Hesitation during acceleration is another symptom. The engine stumbles or hesitates when you try to accelerate from a stop or when merging onto the highway. You've checked for misfires, replaced spark plugs, cleaned the fuel injectors, and nothing helps. This is often corrupted fuel trim data, causing momentary lean or rich conditions during throttle transitions. A reset clears those corrupted fuel trims and forces the computer to calculate fresh values based on current oxygen sensor readings. The hesitation disappears because the computer is now delivering the correct amount of fuel during acceleration instead of using bad historical data. Check engine lights for lean or rich codes like P0171 or P0174 are frequently fixed by this reset. These codes mean the computer detected fuel mixture problems, but they don't tell you why. Often, the why is corrupted long-term fuel trim data that has drifted so far from zero that the computer thinks there's a problem, when really, it's just looking at bad adaptive values. Reset the computer, clear the codes, and complete the relearn drive cycle. The long-term fuel trims return to near zero. The computer recognizes normal operation, and the check engine light stays off permanently. When not to perform this reset. As powerful as this reset is, there are specific situations where it won't help and might actually make problems worse. Understanding when not to use this reset saves you from wasted time and frustration. Never perform this reset if your Chevrolet has confirmed mechanical failures. A slipping transmission with burnt fluid isn't going to be fixed by resetting the computer. Burnt transmission fluid means clutch packs are worn and need replacement. No amount of computer resetting will restore worn friction material. You'll waste 30 minutes, achieve nothing, and still need the mechanical repair. Similarly, don't use this reset for engine problems with confirmed bad parts. If you have a misfiring cylinder and compression testing shows low compression from worn piston rings or burnt valves, resetting the computer won't help. The mechanical damage still exists. Fix the mechanical problem first, then use the reset to clear any adaptive data that accumulated while the engine was running poorly. Don't perform this reset immediately after major repairs or component replacements without good reason. If you just had your transmission rebuilt with all new clutches and fresh fluid, the shop should have performed a proper reset and relearn cycle as part of the repair. Doing another reset immediately serves no purpose and just makes the computer relearn everything again unnecessarily. Avoid this reset if your check engine light is on and you haven't diagnosed the actual problem yet. The reset will clear the check engine light temporarily, but if there's a real underlying issue, the light will come back within a few drive cycles. All you've accomplished is temporarily hiding the problem instead of fixing it. Diagnose first, fix the actual problem, then use the reset if needed to clear lingering adaptive data. Don't use this reset as regular maintenance or on a schedule. This isn't like changing oil every 5,000 miles. You only perform this reset when you have specific symptoms indicating corrupted adaptive data. Doing it randomly or frequently can actually cause problems by constantly wiping learned data that was helping your engine and transmission run properly. The advanced reset nobody talks about. Here's the reset variation that dealers really don't want you knowing about. This is the enhanced version that goes beyond a simple battery disconnect and addresses problems that a standard reset won't fix. For stubborn transmission problems that don't respond to a basic reset, there's an additional step mechanics use called a TCM power cycle. After disconnecting the battery and waiting 30 minutes, you also need to disconnect the transmission control module connector before reconnecting the battery. On most Chevrolet trucks, the TCM is located under the dashboard on the driver's side or mounted on the transmission itself, depending on model year. Find the connector, unplug it, wait 5 additional minutes, then plug it back in before reconnecting the battery. This ensures the transmission module specifically gets a complete power cycle separate from the rest of the vehicle. For persistent throttle lag or drive-by-wire problems, there's an enhanced throttle reset procedure. After the standard battery disconnect, when you reconnect and turn the key to on without starting, press the gas pedal all the way to the floor and hold it for 15 seconds. Release, wait 10 seconds, then repeat 2 more times. This forces the throttle position sensor and electronic throttle body to relearn their full range of motion. For check engine lights related to emission systems, particularly catalyst efficiency codes or oxygen sensor codes that keep coming back, try this variation. Disconnect the battery as normal, but before reconnecting, unplug all 4 oxygen sensors. Let everything sit for 1 hour. Plug the oxygen sensors back in first, then reconnect the battery. This forces the oxygen sensor adaptive data to reset completely, which often clears persistent catalyst codes caused by confused sensor readings. Some advanced Chevrolet owners use a tool called a battery maintainer during the reset process. Instead of completely disconnecting the battery, they connect a maintainer to provide just enough voltage to keep radio presets and clock settings, but not enough to keep the modules powered. This gives you the benefits of a full reset without losing your saved settings. The maintainer needs to be set to exactly 9 volts for this to work properly. The battery disconnect reset is the single most powerful free diagnostic tool you have for fixing computer-related problems in your Chevrolet. It costs nothing, takes 30 minutes, and fixes problems that dealers charge hundreds or thousands to repair. Over the 17 years I've worked on these trucks, I've saved customers tens of thousands of dollars with this simple procedure. The key is understanding when to use it and following the complete procedure correctly. Don't just disconnect the battery for 30 seconds and expect miracles. Follow every step. Drain the capacitors by pressing the brake and horn. Wait the full 30 minutes minimum. Perform the complete relearn drive cycle. These details separate success from wasted effort. If you're experiencing transmission hunting, rough idle, throttle lag, mysterious check engine lights, or any of the other symptoms we discussed, try this reset before spending money on repairs. At worst, you waste 30 minutes and learn the problem is mechanical rather than computer-related. At best, you completely fix the problem for free and avoid an unnecessary dealer visit. Remember, this reset specifically addresses corrupted adaptive data in computer modules. It's not a cure for mechanical wear, failed sensors, or damaged parts. Diagnose properly, fix real problems when they exist, then use this reset to clear the adaptive data that accumulated while your truck was running poorly. One final warning: if you perform this reset and symptoms return within a few days or weeks, you have an underlying problem that needs proper diagnosis. The reset is not a permanent band-aid for ongoing mechanical or electrical failures. Use it as a diagnostic tool and problem solver, not as a way to avoid fixing real issues. If this reset just saved you hundreds in dealership diagnostic fees and unnecessary repairs, share this information with other Chevrolet owners who need to know about it. Dealers won't advertise this because it eliminates a significant revenue stream, but you just learned the exact same procedure they use and charge $150 to perform. Your Chevrolet runs better, your wallet stays fuller, and you gain knowledge that lasts the lifetime of vehicle ownership.